Assalamualaikum and good day everyone. Let's continue with part 3, design process for timber beam. There are 5 principal considerations in designing a beam. First, bending. Second, shear. Third, bearing. Fourth, lateral stability. And fifth, deflection. Most of the timber beam are designed as a simply supported beam. Let's look at one by one on the principal consideration or checking. The first one is bending. We have to calculate applied bending stress using this formula where grade bending stress parallel to the grain equal to MA, which is the maximum applied bending moment divided by Z, elastic section modulus, usually at x-axis. Then we calculate the permissible bending stress given by this formula, which is grade bending stress. This is obtained from Malaysian standard times with the modification factors. The modification factors involves are duration of loading K1, K2 is load sharing, K5 form factor, and K6 depth factor. Then we have to make sure that the applied bending stress is equal to permissible bending stress. The second consideration is shear. Permissible stress given in Malaysian standard related to the maximum shear stress parallel to grain for a particular species or strength class. This is the beam cross section and its shear stress diagram. If you see here, the maximum shear location located at the neutral axis. Therefore, the shear stress, maximum horizontal shear stress is equal to 1.5 V over A, where V is the vertical shear force and A is the cross-sectional area. To calculate permissible shear stress, the formula is grade stress parallel to grain. We can obtain this from the Malaysian standard times with the modification factors. The modification factors involved are K1, this is for duration of loading, K2, load sharing, and K4, shear at the notch end. We have to make sure that the applied shear stress must be less than the permissible shear stress. The third principle is bearing. The behavior of timber under action of concentrated load, for example, at a position of support, is complex and influenced by both length and location of bearing, as shown in this figure. We have the bearing at any length, bearing more than 150 mm, and bearing less than 150 mm. So for this one, we have to refer to table 6 in Malaysian standard. The grade stress for compression perpendicular to grain is used to determine the permissible bearing stress. So the formula is grade stress of compression perpendicular to grain times K1, K2, and K3. The actual bending stress is determined by this formula, which is the actual bearing stress is equal to P over A. So P is the applied concentrated load and A is the actual bearing area. The actual bearing area is the net area of the contact surface, and allowance must be made for any reduction in the width of bearing due to the wane, as shown in this figure. So this is the contact bearing width. In timber engineering, pieces of wood with wane are frequently not used, and consequently, this can be ignored, right? So at the end, we have to check that the actual bearing stress must be less than permissible bearing stress. The fourth principle is lateral stability. Beam with depth and length are large in comparison to the width. That means the cross-section is slender. It may fail at the lower bending stress due to the lateral torsional buckling as shown in this figure. And that was why we have to put a restraint, okay, in order to prevent the lateral movement. The critical value for bending moment which induce this type of failure, such as cross-section dimension, shape, modulus of elasticity, shear modulus, span, degree of lateral restraint, and also type of loading. So how we want to check this lateral stability for the beam is by comparing our maximum depth to maximum breadth for our beam with the one that's specified in table 7 Malaysian standard. So it starts with the limit ratio of 2 where no restraint is provided to the beam to a maximum 7 for the beam where the top and bottom edge are fully restrained. The last criteria we should check is timber beam deflection. The deflection for timber beam is due to the bending and shear. In general, total deflection due to bending and shear should be less than 0.003 times beam span or 14 mm, whichever lesser. Limitation to minimize the risk of cracking, damage to brittle finish, unsightly sagging or undesirable vibration. For solid beam timber, the deflection should be calculated using minimum modulus of elasticity for the strength group or species and grade. The maximum shear deflection induced in single-span seamless supported beam for rectangular or square cross-section can be determined using this formula. So this is deflection due to the shear is equal to 19.2 mmax. So mmax is the maximum bending moment divided by AE. A is a cross-sectional area and E is modulus of elasticity taken as E minimum. These are the guideline or formula to analyze simply supported beam with various load such as UDL, then point load at the midspan, and point load somewhere on the beam length. We can use this formula to get our load at support or shear force, maximum bending moment, and also maximum deflection. Other types of loading arrangement is presented here.